Hello everyone, I'm Shruti Vijayarji from BISP Solutions, and my topic is two sample t-test with equal variances. So when we now consider an experimental design where we want to determine whether there is a difference between the two groups within the population. For example, let's suppose we want to test whether there is any difference between the effectiveness of a new drug for treating cancer. So an approach is to create a random sample of 40 people, half of whom take the drug and half take a placebo. For this approach to give valid results, it is important that people be assigned to each group at random and such samples are independent. When the population variances are known, hypothesis testing can be done using a normal distribution, as described in comparing two means when variances are known, but population variances are not usually known. The approach we use instead is to pull sample variances and use the t-distribution. So in t-distribution, there can be three cases. First one is the equal variances, then unequal variances, and then paired samples. So first I am going to deal with the equal variances. Okay. So for equal variances, we need to know three things. So first one is the t-test, and with the help of this formula, and then we had to know about the standard deviation with the help of this formula and the degree of freedom. Here x and y be the sample means of two sets of data of size nx and ny. If x and y are normal, or nx and ny are sufficiently large for the central limit theorem to hold, and x and y have the same variance, then the random variable t will be calculated with this formula with the degree of freedom this. And as is, I say is the standard deviation, and eh, with a pool Sx and Sy, and S square is also referred to as pool variance. And so this calculation is very uh, is not considered if we do manually. So I'm going to explain you how this will be calculated in Excel. So the particular t-test So particular t-test we are going to run is for equal variances. There are actually three different types of t-test in Microsoft Excel. So the t-test for two sample assuming equal variances is performed when you have different groups and you know that the variances are the same. And another piece of information that we know about that the variances are equal. So this is a very rare case. We know that variances are equal. So in most cases, we want to run the other cases, which is assuming unequal variances. But in this case, we are going to tell the variances are equal. So we are going to go ahead and run t-test for equal variances. For this, I have in some information a marketing research from test the effectiveness of new flavoring for leading beverages using a sample of 20 peoples, half of whom test beverage with the old flavoring and the other half who test the beverages with the new flavoring. So the people in the study are then given a questionnaire which evaluates how enjoyable the beverages was. So determine whether there is a significant difference between the perception of these two flavorings. So to calculate this, just go to the data tab and go to the data analysis tab, and then from here select t-test to sample assuming equal variances, and then click OK, and then select the range for the first so select the range, and then select the range for the second variable. And I did include labels, so I just stick labels, and here hypothesis mean difference is 0. Hypothesis means difference is usually 0. In this case we are hypothesizing there is no difference between the means. so that's why I'm going to put it 0. And here alpha level is 5% or 0.05, so I'm going to keep that as is. It is a pretty standard level for hypothesis test. Now the output range, I'm selecting my output range here and then click OK. So this will be our output. So here are the two means for the old and variant new, and here's the variances for both, and the observations, there are total number of 10 observations. Then pooled variances, which we are not really need for analyzing this particular test. Then there's a hypothesis mean difference, and which we put 0 in our data analysis. And there's a degree of freedom is 80. Now the T is statistics. Now the T critical 110 and T critical 210 and p values. If the T critical is less than T statistics, if T statistics less than the T critical, so we cannot reject our hypothesis. But in this case, T statistics is more than the T critical, so we have to reject our hypothesis. And here is the p value, and p value, if we compare p value with T critical, here the p value for 210 is greater than the alpha level, so we cannot reject this hypothesis. So this is how test for equal variances works in Excel. If you have any doubts, you can ask me. Thanks for watching.